All right, everybody, give me 1 minute and we're about to get started. Okay. Potentially. It works. Great. Well, it works. A lot of troubleshooting. Sorry for the delay. Good afternoon, everyone. I'm Andukimali Madalinige, and welcome back once again to Side Trends, and welcome to my full coverage of the 2024 total solar eclipse live stream. So, as we speak, the moon is embarking on that celestial journey across the vast expanse of space, positioning itself directly between the Earth and the Sun, which creates what we know as a solar eclipse. Who's excited? Because, oh my god, I am. I am so lucky to be able to not really move at all and be able to see this eclipse. It's gonna be amazing. It's gonna be so awesome. It was supposed to be cloudy today, but as you can see, we've got sun. We've got sun, and that's great. And that's amazing. And we're truly lucky to just be here and enjoy the moment, you know? So, what's happening right now? Basically, a solar eclipse occurs when the moon's orbit passes directly between the Earth and the Sun, which casts a shadow on the Earth's surface. The moon's shadow has two parts, the umbra and the penumbra. You guys can see that graphic here. It's my first time using this software, so bear with me. I'm trying my best. Oops. We're gonna pretend that never happened. The umbra and the penumbra, and the darker inner shadow is that penumbra, and then the umbra is that lighter gray shadow. And in the umbra you will see a total eclipse, and in the penumbra you're gonna see a partial eclipse. And that umbra creates a path of totality which is spanning around 120 miles wide, and it's going to be 2,500 miles across that globe. That's a lot of miles, and that's going to create a giant shadow. This is going to be breathtaking. This is going to be amazing, and I'm truly honored that I am able to bring this to you guys live with my commentary. Oh my god, it took forever to set this thing up. I'm still figuring out, you know, how this works and everything, so bear with me. This is a process that we're just gonna have to go through together, but I'm trying my best to bring you all this solar eclipse live stream. All right, we're gonna be right back in just a few minutes. All right, everybody, just took a short break. Got to get some water. Get your sunscreen. Very important. Get that sunscreen on, especially, obviously, it's sunny. Get it on. SPF 30 plus right now. So let's talk about the different types of solar eclipses. A partial solar eclipse is when the moon's orbit passes in front of the sun, but not directly, so it's not going to completely block that sun. So it's going to look something, again, truly amazing technological skills here. It's going to look something like this. As you can see, there we go, on your screen right now. Let's get rid of that real quick. Okay, and then An annular eclipse is when the moon passes in front of the sun. However, its orbit is just a little bit too far away for that full total coverage. So it's going to be like a ring of light. There's still going to be a ring of sunlight around the moon's shadow, but regardless, it's still pretty cool. And what's going to be happening today is this beautiful total solar eclipse where everything aligns perfectly and the moon passes directly in front of the sun, getting an image like this that we see here. Honestly, I'm so excited because my last it was a total solar eclipse, was in 2017, and where I live, we didn't get the total coverage, but we still got a partial eclipse. But I remember that day so well. It was such a breathtaking moment. It really solidified that I wanted to do space science in the future, and I still want to do that, so I think that's pretty cool. We have the privilege of being in the path of totality this year. We were praying for that good weather, and it delivered. It's a nice, bright, sunny day. You can hear the birds. You can feel the breeze. It's just a beautiful day, and I'm so honored to be able to share this event with you guys. So let's talk about the rich historical and cultural significance of solar eclipses. Now, as you can imagine, science has progressed a lot from the ancient times towards now. And the cultural significance of these solar eclipses really varied from society to society. The Mayans, for example, saw eclipses as cosmic battles between the sun and the moon, and each celestial body represented a deity. Another very interesting thing is that the ancient Chinese believed that a solar eclipse was basically a dragon eating the sun, which I think is pretty cool. And this picture, this artwork here, kind of like showing you what they believed. I think it's pretty cool. And they believed that the celestial dragon would come and eat the sun, which I think is pretty epic. Celestial dragon, that's pretty cool. And the ancient Greeks, they believed eclipses were signs from the gods, a bad omen. And actually, in 585 BC, it was thought to be 585, but the exact date is unknown. A Greek philosopher predicted the solar eclipse, which is incredible based on so far back, and they were still able to do this. And at that time, at that day, there was a war between the kingdoms of Lydia and Medes. I believe I might be saying that wrong, so please excuse my bad pronunciation. And during that solar eclipse, everything stopped. All the fighting, everything. And they all took it as a symbol from the gods, like, this is a bad omen, right? And so the fighting completely stopped. And the two kingdoms came to, be peaceful with each other. And they even arranged a marriage between the princess of Lydia and the prince of Medes. So solar eclipses have been continuing to fascinate and intrigue people around the world, creating different beliefs, inspiring that connection. And I feel like solar eclipses really unite us as people, regardless, because it's just such a beautiful event. It's such a beautiful celestial phenomenon, and it's just so beautiful. I think it's amazing that we have that privilege to be able to see the eclipse, and now we're really good at predicting them too, so I think that's pretty cool. Be right back. So, let's take a little break from talking about all that science. I hope everyone's as excited as I am, because dang, I am so excited. I mean, this is just gonna be so amazing. It's gonna be wonderful. And oh my god, it took forever to set this up. Like, it took a long time to figure out like what's going on, so please bear with me as I work on graphics and all that. You know, it's just a beautiful day. I smell barbecue. Someone's cooking something. I want some barbecue. But, you know, water's pretty good too. Oh, I must reiterate, sunscreen. Sunscreen. Now, put it on. If you're outside, put on your sunscreen. Do it. It doesn't matter. Just do it. All right. Let's talk about the corona. The corona is that outermost layer of the sun's atmosphere, and we can see that in this picture. Great picture. Taking these off the internet as one does. And so these are examples of sun's corona, that outermost layer of the atmosphere. Now, during totality, we will be able to see this corona, and that allows scientists a unique way to just understand more things about our sun in general. Oops, shoot, I hit my elbow on the table. It happens. So during totality, we'll be able to see this corona. And this brief window of visibility allows researchers to investigate the corona's temperature, density, and magnetic structure in unprecedented detail. They'll also be able to see fundamental processes such as solar wind acceleration and coronal heating mechanisms. In addition, solar eclipses have played a very crucial role in advancing our understanding of solar physics. By observing these coronal events, scientists have been able to make many big breakthroughs in areas such as solar flares or coronal mass ejections. A coronal mass ejection, do I have a picture? Oh, dang it, I don't. I don't have a picture. But I can pull one up right now and show you guys from my iPad, because I can do that. A coronal mass ejection. I thought I had that graphic. My bad, guys. I'm still a teenager. Cut me a little slack. Okay. This is what a coronal mass ejection looks like, and it looks like that. Pretty cool, huh? Yeah, so that is a coronal mass ejection. And one second, let me find it. It's okay. So coronal mass ejections, I've always wanted to see one, and they can cause a lot of, along with solar flares, which are sudden eruptions of electromagnetic radiation and charged particles. They can interact with our Earth's magnetosphere and they can disrupt satellites. They can trigger geomagnetic storms, and they can basically do a lot with our technology in general. Like, we are so dependent and very prone to these celestial events coming from our sun, and we can understand those things through solar eclipses, because we could see that corona so clearly. Oh, my dog. Bye, Pinchy. Sorry, I saw my dog. I love my dog. But we can safeguard our technology-dependent society by learning more about solar flares, coronal mass ejections, and all those things through solar eclipses, which is really, really cool. A very interesting scientific discovery that happened during a solar eclipse, well, it wasn't a discovery really, it was more like proving a scientific theory. You guys know about Einstein's general theory of relativity, right? So this was proved in 1919 during a solar eclipse, where astronomers saw that stars near the edge of the sun appeared to be in a different place from they originally were. This proved that massive objects like the sun can bend the fabric of space-time, which causes light to follow curved paths. This was Einstein's theory, and it ended up being proven in the real world by this solar eclipse, which I think is pretty cool. I think that's amazing. It's wonderful. This revolutionized scientists' understanding of gravity and the cosmos. Pretty amazing. Pretty amazing. Yeah. Until I'm not that prepared, but it's okay. Trying to take this in. We're minutes away actually from the beginning of the eclipse itself. And what will happen is we're gonna switch to a different camera so then we can bring you a very close up, like live view of the eclipse itself. So what will happen is this stream that you guys are watching, hello, the 4 people who are watching, thank you for watching. You guys are amazing. I don't know who you are, but thank you. I will be switching to another camera and we will be live streaming from there. So then we can put our solar filter on and then we can get a very, very close up view so we can watch this eclipse together, which will be really cool. Now let's talk about those eclipse chasers, because oh my goodness, are they dedicated. Eclipse chasers, they go everywhere and they look for eclipses. They are the people who I strive to be, but I'm not that rich. I can't go like take a plane every single time to go chase an eclipse, but these people can. They consider a lot of different factors, like where it is, the weather, exact like locations, and these people are dedicated. Like Airbnbs in the path to totality this year, almost all of these Airbnbs are booked, which I think is insane. The dedication is awesome. I wish I could do that, man. I wish I could just eclipse chase the rest of my life, because that would be amazing. That would be so cool. Now let's talk about wildlife. Your dogs are gonna act differently. I don't mean your feet, I mean like your actual dogs, okay? Like pets. Because a lot of animals are going to be very, very confused during this solar eclipse. So birds have been observed to come together and roost as if they were preparing for nightfall. A lot of nocturnal hunters like owls and bats, they're gonna come out and take advantage of the confusion of the prey, such as like mice and other rodents. Honestly, shout out to the nocturnal hunters. They take advantage of everything. I love bats, I love owls. They are very smart, intelligent creatures who, as we say, go get the bag, go capitalize on the solar eclipse, if you know what I mean. And honestly, I just can't wait to see how my dog reacts, because she's gonna be so confused, because it's gonna get dark. It is going to get dark, because, I mean, you're completely blocking the sun. So obviously things are gonna get dark. It's going to be so cool. I cannot contain my excitement. I'm having trouble relaying all this information that I have to you guys because I'm just so excited for this. It's gonna be amazing. It'll be awesome. It'll be so awesome. All right, I'm gonna take a water break. Be right back. Okay, I'm back. I am back and I am doing great. Took a water break and now let's get back into it. Let's delve deeper into the extraordinary advancements in technology that have revolutionized our understanding of solar eclipses and the sun itself. Digital photography has played such a pivotal role in transforming how we capture and document solar eclipses. I mean, just look at these images. Just look at them. Beautiful. Now we don't have to rely on just film cameras. We can take pictures of solar eclipses on our phones. We have the power to take a picture of a celestial event on our phones. It's just amazing. And satellite imagery and space-based telescopes have provided astronomers with an unparalleled view of the sun's surface and atmosphere. Instruments such as the NASA's Solar Dynamics Observatory, SDO, and the European Solar Agency Solar Orbiter offer a front row seat to solar phenomena in action, including those solar flares, coronal mass ejections, and sunspots. You know what? This picture right here, if you look close enough, right there, those are sunspots. Those little spots you see, those are sunspots, which I think they're amazing. And these space-based observatories continuously monitor the sun's activity, which provides a valuable data for understanding solar variability and its impact on space weather. And recent scientific discoveries related to solar eclipses have deepened, as I said, our understanding of the sun's magnetic field, solar wind, and variability. We can also gain insight onto the processes that drive solar activity and influence the Earth's climate. For example, observations of the corona's magnetic structure have revealed, and I'll kind of picture for you guys because I have a picture for this one, coronal holes. They have revealed the presence of these coronal holes, which are regions of reduced density and temperature that are associated with the solar wind and geomagnetic storms, which I think is amazing. There's a lot that we can do with solar eclipses and just observing the sun in general. Oops. Bear with me here. Told you, still learning. There's my graphic, my bad. Modern eclipse observations will really engage people in the public, because I mean, not all of us are going to be scientists, not all of us are scientists, but there's just this wonder of looking up and seeing a celestial phenomenon just like in your backyard, and it creates a deeper appreciation for the wonders of our solar system. Okay, this is a very important thing, as the eclipse is going to start very soon. We need to talk about safety, because safety first. Remember, do not look directly at the sun. I think I'm going to say that again. Do not look directly at the sun. Do not do it. Not even if it's 50% covered, not even when it's 99% covered. The only time it is okay to take off whatever protection you have is 100% coverage, full totality. When you are viewing a solar eclipse, you have to prep yourself with proper eye protection, such as solar viewing glasses, eclipse glasses, like these. These ones are damaged, but I'm using this as an example. These need to be with the International Safety Standard ISO 12312-2. They need to be approved and have that safety standard. You have to verify that certification before use. I got these off of Amazon, pack of 5. And you have to make sure that it's a reputable source with that ISO 12312-2. Always look for that. Remember to check for scratches and tears, because that will impact your ability to use them. Never use solar eclipse glasses with tears or scratches or anything like that. You must dispose of these immediately if you see some sort of defect. I'm just using this as an example, even though it has a defect, to just show you guys what these look like. You put them on like this. I'm not gonna look at the sun with these, obviously, but yeah, you should be wearing glasses. There are also handheld viewers that you can use, and those are safe to view the solar eclipse with directly. And if you don't have access to that, there's another really cool thing you can do. You can make a pinhole projector, which looks like this. There are many tutorials on how to do it, and allowing that sunlight to go through that tiny pinhole, you can get that projected image, and you can see the eclipse happening on that piece of paper. Remember this very well. Never look directly into the sun. Don't do it. Don't even think about it. Don't even try it for fun. This is not a funsy situation, because it would not be fun if you went blind. So do not look directly into the sun. I think I need a graphic for that. Do not look directly into the sun. That is just a no-no. Remember, always supervise your children if you're an adult and you're showing your kids like the solar eclipse. That's great. Make sure they're wearing those glasses unless it's like full totality, then they can take it off. But never look directly into the sun. Never do that. Always use protection. Always have something like those glasses or a pinhole protector or something like that. Always. Okay guys, we're getting ready for the eclipse to start because it's literally about to start right now. What's gonna happen is this specific stream is going to end, and we will have the actual stream up because we need to get our other camera and put this solar filter. You can actually put one of these on your phone, which I think is pretty cool. And we will be bringing you the direct live stream of this solar eclipse. So yeah, so we'll be right back with that.